Welcome to the second part of the presentation on basic trigonometry. In the last 10 minutes, I had trouble getting a lot of examples, so I want to do a couple of more with you guys. Okay, so let me start over just because this got messy. And we're just going to do what we did the last time around. So let me just draw another right triangle. Let me make sure it's not going to be too big. Okay, so here's my right triangle, and let me just throw out some random sides. Let me say that this is 6. This is, let's make this side 5. And then if this is a right triangle, Pythagorean theorem tells us that this would be the square root of what? 36 plus 25 is equal to the square root of 61. I think that's right. I've gotten feedback on some of my other videos that I tend to get this type of addition wrong. I malfunction sometimes. But anyway, so this side is the square root of 61, and that's the hypotenuse. So let's get started with some problems. If I were to ask you, well, let's see, let's call this angle theta. And I want to know what is the tangent of theta? And we'll shorten that as tangent of tan of theta. What is the tangent of this angle right here? Well, you probably already forgot what the definition of tangent is, so I will repeat it. In fact, I will write up in this corner, SOHCAHTOA. So I think now your brain might be refreshed, and you'll remember that TOA is the mnemonic for tangent. And it says that tangent is equal to the opposite over the adjacent. So the tangent of theta is equal to the opposite side. Well, that's this side. That's the side that's length 5 over the adjacent side. That's this side, the side of length 6. That was pretty easy, huh? The tangent of theta is 5 over 6. And we'll just do a couple more. We'll just go through all of the trig functions, or at least the basic trig functions. What is the sine of theta? Well, let's go back to our mnemonic. SOHCAHTOA. This is one of the few things in mathematics that you should probably memorize. It's kind of a funny word anyway. And so defines sine and tells us that sine is opposite over hypotenuse. Opposite over hypotenuse. Well, the opposite side, once again, is 5. And what's the hypotenuse? Well, the hypotenuse we just figured out was the square root of 61. The square root of 61. And a lot of people don't like irrational denominators, so we can rationalize the denominator. And we do that by multiplying the numerator and the denominator by this square root of 61. So if we say that this is equal to 5 over the square root of 61 times the square root of 61 over the square root of 61, right? We're just multiplying it by 1 because this is the same thing, top and bottom. This equals 5 square roots of 61 over, what's the square root of 61 times the square root of 61? Oh yeah, it's 61. So the sine of theta is 5 square roots of 61 over 61. And then finally, let me make some space here. Let me erase some stuff. Let me erase this one right here. And you're probably still wondering, okay, I kind of get this whole sine, tangent, cosine thing. What is it useful for? And all I can tell you right now is get to know how to use these SOHCAHTOA, and in the next presentation and onwards, we're going to show you that trigonometry is actually probably one of the most obviously useful things in math. You can figure out all sorts of things, how far planets are, or how tall buildings are. I mean, there's tons of things you can figure out with trigonometry. And later we'll study sine waves and cosine waves and all of that. And you'll learn that it actually describes almost everything. But anyway, going back to the problem, all we are left now is cosine. Oh, look how big that is. Cosine of theta equals. We'll go back to our mnemonic. SOHCAHTOA. Well, cosine is adjacent over hypotenuse. So once again, what's the adjacent side? Well, this is the angle we're finding the cosine of, so the adjacent side is right here. It's a length 6. So it equals the adjacent side, which is 6, right? And we figured out what the hypotenuse was. That's this side. It's length square root of 61. And if we rationalize this denominator, we get 6 square roots of 61 over 61. It's kind of messy numbers. But I think now you get the hang of figuring out, if you know the sides of a triangle, figuring out what the sine, the cosine, or the tangent of any given angle in that right triangle is. And obviously you can't figure it out for this angle, because for this angle the opposite and the hypotenuse are actually the same number. So actually, never mind. You actually can figure it out, but it actually gives an interesting number. So with that said, I will finish this presentation, and then in the next presentation I will show you how, if we know what the sine or the cosine or the tangent of an angle is, and we know one of the sides, how we can figure out the other sides. See you in the next presentation. Bye.